Good morning, everyone. Let's wait another minute. We only have 8 students here right now. We'll just hang tight for a second. Okay, let's get started. So I sent out an email. I'm sure you got a notification somehow from the college that they've extended the at-home thing for another week. So we were going to go back next week, but we're not. So according to what the college has said, we will be returning on campus on, well, for us, it'll be Tuesday the 8th is when we would go back and be on, have our first like face-to-face class. We'll see, right? We'll see what happens. I think they're waiting for this peak to end. We'll see. But we're just going to keep trucking along here, and you know, we're gonna keep our tests the way it is scheduled right now for next Tuesday, and you'll be coming in to the Zoom session and you'll be doing your test via Zoom. All right. This first test is going to be relatively short. Well, not short. It's going to have very few topics on it. I'm working on the review right now, so I would expect that I'd send out that review sometime today, and then I'll send out the solutions to the review. I don't know, maybe Friday or Saturday. All right. Any questions on that? We're good. Okay, thank you, Raymond. All right, so today we're going to really just focus on one concept, solving linear equations, and really want to kind of take our time on this because as we move through this class, if you can't solve linear equations, it's going to cause problems later. So we want to make sure that we understand how to do this. So I want to start by discussing, you know, what is a linear equation first, like what is it? And then I'm going to go through like the procedure or the set of steps that we take to solve a linear equation. So first of all, what is a linear equation? I'm sharing my screen. Yes. What is a linear equation? Well, there's a couple of things that make a linear equation a linear equation. The first thing is that you have an equal sign. So somewhere in the problem, you see an equals in there. Okay, that's what makes it an equation. All right, that's what makes it an equation. And then the second thing is that you have a single variable which is raised to the first power. And that is what makes it what we call linear. Okay, so it's the equal sign that makes it an equation. It's that we see a single variable raised to the first power that makes it what we call linear. And later on, we'll be studying quadratic equations, and then polynomial equations, and then rational equations. So we need to be able to distinguish between these things. So here's your first kind of example of a linear equation. And I realize that a lot of you have seen this and done this and everything. Great. If you're good with this, wonderful. But let's just start out very basic. If I write x plus 4 equals, let's say 10, okay, that is a very, very basic linear equation. We see that it's an equal sign, right? So we have an equation. And then the part, like I said, that makes it linear is that we have an x and that x is raised to the first power. So there is a power on that x, a number up as an exponent of a 1. Now, if we saw a 2 up there, it would not be linear. If we saw a 3 up there, it would not be linear. Here, there's a 1 up there. So anytime you see the variable without any power written up there, right? If there's nothing written up there, it's understood that it's a 1. So that's what makes it linear. And our goal, our task, okay, the goal of solving, when you solve this, what you're doing is you're trying to find the x which makes the equation true. All right. So I'm trying to figure out, let me write the problem down again here. I'm trying to figure out what does this x need to be to make the left side of this equation be equal to the right side of the equation. So you can actually solve this probably by just looking at it, right? Like, what number plus 4 gives you 10? What?
6.
6, right? So that's something we could solve this equation just visually, just by looking. And we say, oh yeah, x is 6. Sure. Okay, yeah, that makes sense. But what we want to do is we want to have a procedure or a set of steps that allows us to solve some linear equation if it's not so easy to do. Like if I just wrote this down, and said, okay, what makes that true? You're not going to be able to just look at it and say, oh, x is 6, right? It's a much more complicated problem. So we need some sort of procedure, right? Some sort of steps so that we can get to the answer, all right? So what are the things that we do? What are the steps? What's the procedure for solving a linear equation? I'm going to write them out first. Okay, I'm going to write all the steps out first, and then we're going to just start using those steps to do examples. All right. So here is the steps to solve a linear equation. All right, here they are. The very first step is to make sure you have a linear equation. Right, so you're going to just want to be able to look at the problem and say, oh yeah, that's a linear equation. That's the very first thing, is the identification. And then later on, when we get to quadratic equations, the very first step will be, hey, make sure it's a quadratic equation. All right, so even though that step is kind of like obvious, we want to be able to distinguish equations from one another. So make sure it's linear. Once we know it's linear, the next thing we're going to do is we're going to clear fractions or decimals. Now, when I'm writing these steps down right now, you may be like, well, I'm not sure what you mean by that. Just wait. When we start doing examples, we'll actually see these steps illustrated. All right. So after we identify it's a linear equation, we're going to look at it and we want to clear any fractions or decimals. Now, to do this step, what we're most likely going to do when we get to the step is we're going to multiply or divide both sides of the equation by some number. Okay, so this is kind of like, we're trying to clear fractions and decimals. And to do that, what we'll be doing is multiplying or dividing both sides of the equation by some number, all right? Once we have done that, we've cleared fractions or decimals, we are going to clear any parentheses. Hold on a second. We got to do something. Sorry. I forgot. I've got to turn something off before I. Okay. sorry about that. Let's see. Clear parentheses. Now, what we'll normally do to do this is distribute. Okay, now again, I'll explain that more when we get to the step. All right, we'll distribute. Then the next thing we're going to do is we're going to combine like terms. And for this, we're basically, oh wait, hold on, let me see. Combine like terms on each side of equation. And for this, we're going to basically what we're doing here is we're going to put the x's together. And then we're going to put the numbers together. And we do that on each side of the equation. The next step is to isolate the variable. And what that's going to mean is basically move the x's to one side of the equation and move the numbers to the other side. So we will be isolating the variable. Almost done. Next thing we will scale the x term so it has a 1 in front of it. And to do that step, we're either going to multiply or divide both sides of an equation, both sides by some number. Okay, that's it, all right? That's the procedure. So let's do an example, all right? Let's do an example. And let's do, I'm gonna take this and move it up a little bit here. I'm gonna copy this. And then when we do our example here, I'm gonna have this pasted here, but I'm gonna make it kind of small so I can refer back to it, but I don't want it to take up all the room here. So I'm just gonna kind of put this over here to the side. I know you may not be able to read that, but you've got it there if you've written this down. Okay, here we go. First problem, first example. Well, let's go back to the one that was very easy. X plus 4 equals 10, right? We just looked at that and we knew the answer was 6, right? Just by looking, 6 plus 4 is 10. Okay, but let's just act like we didn't know how to do that. Let's follow the steps. First step, make sure it's a linear equation. Well, it is, right? We see an equal sign, we see x raised to the first power. So yep, it's step one's good. All right, next step, clear fractions or decimals. Do you see any fractions? No. Do you see any decimals? Like, 4.25 or something like that? No, right? No decimals. So there's nothing to clear. So step 2 is done. Clear parentheses. Do you see any parentheses? No, right? So step 3 is done. All right. Fourth step, combine like terms on each side of the equation. So first start with the left side of the equation. X plus 4. The variable x and the number 4 are like a dog and a cat, right? You can't put a dog and a cat together. So they're not like terms, so we can't combine them, so there's nothing to do there. And on the right-hand side, we just have a number, and there's nothing else over there, so there's nothing to combine on the right-hand side. There's nothing to do, right? So step 4, got it. All right. Step 5, isolate the variable. Okay, this means we want to get the x's on one side of the equation and anything that's not an x on the other side of the equation. And in this problem, we actually, for step 5, we actually have the x on the left side, but it is not isolated, right? There's that 4 over there with it. So I'm sure you know this, but I'll just remind you, if you want to get this x by itself, you have to get rid of the 4. Since the 4 is being added, you want to undo the addition. So you will subtract the 4, and whatever you do to one side of the equation, you have to do the other side of the equation. So it's like a balance, right? You do something here, you have to do the same thing on the other side to maintain the equality. So now when you take the 4 and subtract the 4, it goes away. That leaves you with just the x. On the right-hand side, you do the 10, take away 4, and you get 6. That's the 5th step. We have isolated the variable, right? It's by itself now on the left side. The last step, step 6, is to scale the x term so that it has a 1 in front. So right here in front of the x, there's a number. And if there's no number written, everyone here needs to know that it is a 1, right? That's 1x. So step 6 says make sure there's a 1 in front of the x, which there is, right? So there's nothing here for me to do as well. So we're basically done. We get 6. Okay, that's a lot of steps to solve a problem we could have done visually, right? But like I said, this is about building up a procedure for a more complicated problem like, where was that one? Where did I put it? Where'd it go? Oh, this one right here. See, like this one. That's much harder. So we'll do that one later. We'll do it in a minute. Let's just kind of work our way up to this. All right, how about this one? All right, how about 2/3 x minus 1 equals 5/7. Nobody here is going to tell me the answer just by looking at that, right? No one here is just going to say, oh, the answer is this, right? You got to do some work here. Now, first step is make sure it's a linear equation, right? So is it linear? Let me grab these steps here. I'll put these down here. So is it a linear equation? You can just nod your heads. Yes, yes, yes. It is linear, right? Step 2, clear the fractions. Do we have fractions? We do this time, right? We do. So what do I mean by clear the fractions? We want to multiply or divide both sides of the equation by some number. But what number? Does anyone know what number I'm going to multiply both sides of the equation by here in order to clear the fractions? Anyone know? Not sure, Brandon? So the way that you figure out what number you use is to look at the denominators of the fractions, okay? You're gonna look at those denominators and you're gonna act like you were gonna add them together. Let's just say we were gonna add those two fractions together. You would have to get a common denominator, wouldn't you? Which means you would have to look at like all the multiples of 3. I'm just gonna write this on the side. You would do like all the multiples of 3, 3, 6, 9, 12, 15, blah, 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 right? And then you write all the multiples of 7, 7, 14, 21, da, 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 da. And what you're trying to find is the smallest number that's in both those lists. So what is the smallest number in both of these lists?
21.
Amory, 21, right? 21. So if you were adding those fractions together, you would try and make their denominators 21, right? That's what you would try and do. That's the number you need to multiply both sides by. All right, that's the number. So here's how I do this. Now, be careful in the way I write this. I'm going to write 21, and I'm going to multiply that times the entire left-hand side of the equation. And then whatever I do to the left side, I must do to the right side. So I do 21 times the right-hand side, which is just 5/7. Now, when I did this, do you all see that I put the 21 and I put the whole left side in parentheses, right? I did that not because I just wanted to. I have to, The 21 is going to multiply times the entire left side, which means it has to multiply times each one of these. So when I do my next step, this 21 is going to have to distribute through this parentheses. All right. So let's do that step. Let's distribute the 21 through. When I multiply 21, this first multiplication right here, all right, that highlighting here in yellow, that first multiplication through, I'm going to write it down right now in detail. It's 21, then I'm multiplying times 2/3 x, right? That's what I'm doing. And then when I do the second multiplication, which is the one here in green, I'm doing 21 times -1, right? That's really what's happening. Or you could write it this way. Let's write it this way. Just bring your minus sign down. And then you're doing 21 times 1. Let's do it that way. Just bring the minus down and just do 21 times 1, put it here. On the right-hand side, we're doing 21 times 5/7. Okay, we good? Now, this multiplication that I'm about to do right here, I'm going to multiply those two numbers together, 21 times 2/3. This is multiplication. This is something that we've already done, right? We talked about this in the last week. Really what we're doing there, if you want to think about it, what we're really doing here is taking 21/1 and multiplying 2/3. So we're like multiplying two fractions. We're just looking at the number 21 as the fraction 21/1. And then you just multiply straight across, which would give you, well, you could say 42/3, like that, right? You could do that. 42 divided by 3 is what? 14, I think, right? You get an answer of 14. Now I can do that, or if I wanted to, before I got to this step here of saying what it's equal to, I could reduce this. 3 goes into 3 once, and 3 goes into here 7 times. And then when you multiply straight across, you get 14/1, which is the same answer. So it's completely up to you how you do that. You just need to know that it turns into the number 14. Are there any questions on that? Good. We have 14x here minus now 21 times 1. That's just 21. And then on the second one, I'm going to do the same thing I did here on this one. Let's just do it over here on the side. This one over here, that's 21/1 times 5/7. And I'm going to do the same thing I did up here. I realized that 7 goes into 7 once, and 7 goes into 21 3 times. And then when I multiply straight across, I get, what do I get? What do I get?
15.
15, thank you. Looks like I'm going to be calling on people. Okay, there we go. Step 2 is done. Notice that we have a new equation, right? Look at this equation. Compare the original equation to this new equation. Our new equation no longer has fractions, right? So the whole step, the whole reason for that step is to make our lives just a little bit easier, because working with fractions can get a little bit complicated and we can make mistakes. So we try and get rid of them to start. And then we have nice whole numbers. And now we just continue with the procedure. So step 3, clear the parentheses. Well, we have no parentheses, right? So step 3, done. Step 4, combine like terms on the left and on the right. So when you look at the left, you can't put those together, right? It's a dog and a cat, can't do that. And then on the right, it's just a number by itself. There's nothing you can do. So step 4 is done. Step 5, isolate the variable. So our variable is not isolated right now, right? We have 14x, take away 21 equals 15. So let's see, Allison, are you here? Oh, wait, hold on. Let's go with Alicia. Is Alicia here today?
Yeah, I'm here.
Okay, how's it going, Alicia?
It's going good.
Good. 5. Wait, today's 27th, right? 27. Okay, so Alicia, if I want to isolate the variable, what are you going to have to do here to isolate the variable?
Would you just add 21 to each side?
Yep, at 21 to both sides. There we go. And then Alicia, what would we get on the left side? What would still be there?
36. Oh, I'm
Okay,
sorry.
that's all right.
14x, and then on the other
14x.
side it'd be 26. Sorry.
36, yes. Okay, right. That's what we have now. So that is step 5. We have isolated the variable. Last step is to scale the x term so that it has a 1 in front of it, right? And let's see, Sarah, are you there?
Yes, I'm here.
Okay. Sarah, so what do I mean by scale this variable term to make it have a 1 in front? What do I want you to do here? Do you know?
No,
No? Okay, so right now, what's the number in front of the x?
14.
14, and that's being multiplied, right? It's 14 times x?
Oh, yeah. Do you want us to like divide that like 14? Okay.
Exactly. So you want to get rid of that 14, and you have to undo the multiplication. So to undo the multiplication, you divide. So I'm going to divide both sides, right, by 14?
Yes.
And then the 14 divided by 14 gives you a 1, which is exactly what step 6 is saying. Get a 1 in front, right? So this gives me just x. And then on the right side, I don't want you to go get on your calculator and do 36 divided by 14.
Okay.
I don't want the decimal answer. I want the fraction answer, but I want it reduced. So I think 2 goes into both of these, right?
Yes.
2 goes into both. 2 goes into the top, I think, 18 times. And 2 goes in the bottom 7. And that is the answer. 18 over 7. What do y'all think? Make sense? Okay. I'm going to do one more. After I do one more, I think, well, I don't know if I'm going to give you one to work on. Let's see. Let's see how the next one goes. All right. Time to throw some more crazy stuff in there. So let's get more complicated here. How about 3x? So this is your next example. 3x minus 2 parentheses x plus 7 close parentheses equals, let's go 5 minus parenthesis x, better make it, hold on. Yeah, go ahead and go x, that's fine. X minus 3. And then, yeah, let's just do that. Okay, we'll do that. So I want us to solve for x here, all right? First step, make sure it's a linear equation. So we have our equal sign. And when I look at the variables, all of them have a first power. So this is a linear equation, all right? So step 1, we're good. Step 2, clear the fractions. We don't have any fractions. We don't have any decimals, right? So we don't have a step 2. Clear parentheses. Now we do have parentheses, right? So I'm supposed to distribute. So that means I want to take whatever's in front of the parentheses, whatever number's in front, I want to distribute it through the parentheses, which means multiply it through. Distribute here, and then on the other side, I need to distribute this minus. So I'm going to treat that as like a -1, and I'm going to distribute it here and here. And again, distribute just means multiply. So we will get, let's see, I'm picking on people who don't have their cameras on. So Allison, are you there?
Yes, I'm here.
Okay. All right. So Allison, how about you tell me what you would get this entire left-hand side, what it would be if you distributed through?
I got 3x minus
so
2x
Minus 2x, good.
minus 14.
There you go. Okay, so just multiplying -2 times x gives you -2x. -2 times 7 gives you -14. Perfect. You want to keep going? You seem like you understand this.
Yes.
Okay,
On the other
good.
side, I got 5 minus x plus 3.
There you go. Perfect. Good job. Everyone see that? Clearing the parentheses. Just got to make sure that when you multiply negative times a negative, you get positive. And if they have different signs, it stays negative. Okay, we've cleared the parentheses. Good, good. Now we're going to combine like terms. So let's go with Kylie. Kylie C. Are you there?
Yes, I'm here.
Oh, your microphone's okay today?
Yes, yesterday it was acting weird.
Okay, I understand. All right, so we're on step 4. We're going to combine like terms, which means we put dogs with dogs and cats with cats, right? So on the left-hand side, what can you combine together?
The 3x and negative 2x.
Yep.
It would just be x.
It would just be X. So really what you're doing whenever you have like terms like that, you're really just looking at the numbers and just adding or subtracting the numbers, right? And then just remembering to stick an X at the end.
Mhm.
So you did like 3 minus 2 is 1, so you just have an X here. And then the minus 14 still here, right?
Yes.
Okay, what about the right-hand side?
Would you do the 5 plus the 3?
Yeah, because those are similar things. Those are like terms, right? And so what about the minus X? How do you want me to write this? You tell me and I'll write it down.
8 minus x.
You could do that, 8 minus X. That's perfectly fine. But just keep in mind, you could also have written it this way, negative X plus 8. These would be the same thing. I'm just putting this on the side. You could write 8, take away the X, or you could put negative X plus the 8. So that order wouldn't matter. Okay, good. We have done the 4th step. We have combined like terms. And now we have to isolate the variable. Now, this is a little weird because we have variables on both sides, right? We have the X's on the left and the X's on the right. So we need to get all the X's to one side and anything that's not an X to the other side. So there is no like, you have to do all the X's on the left or you have to do all the X's on the right. It's completely up to you and me, and every one of you individually can make the decision. Do you want your X's on the left or right? Totally your call. So I'm going to choose to move them to the left. Okay, I'm going to leave this X here, which means I have to get rid of this minus 14. And then on this side, I need this negative X to come over to the left side, right? So let's see. I'm going to call on Jareth. Are you there?
Yes, sir.
Okay. How would you, first let's deal, we're going to try and get the X's on the left. How would you deal with the minus 14 over here? What would you have to do?
You would add it to the 8 on the other side.
Yep, we're going to add it to both sides, right?
Mhm.
And that will have the effect of getting rid of this. And then this minus X over here, Jareth, I want that to not be there. I want it to appear over here. So what would I have to do?
You would add that X to
Add the
the
X.
X to the side.
Good. You add the X here. And it will go away on this side. All right. Good. You want to tell me, Jareth, what we would have? Like what's still over here on the left side?
I2X equals
2X.
22.
2X equals 22, right?
Yes, sir.
Everyone got that? X plus X is 2X. 8 plus 14 is 22. There we go. So we have now done the 5th step. We have isolated the variable. And then let's see, Abigail, you there?
Yes, sir.
Okay. So last step, you want to scale the X term so it has a 1 in front of it. How are you going to do that?
Don't you
So I
just divide
don't
both
want
sides
that
by
2 here. How am I going to get rid of it?
Don't you divide it by 2?
Divided by 2. So we do that here and we do that here. The 2's go away, become a 1. So you just have X. And fortunately for us, 22 divided by 11 is, 22 divided by 2 is 11. There we go. Okay, so just by calling on you all, it seems like there's a good percentage of you here that have seen this, maybe feel comfortable with this, which is good. They're just going to get more complicated. I mean, that's really the thing about linear equations. They just get uglier. All right. So I have one for you to consider. This is going to be actually a very yeah, let's do it. What if I gave you -3 x equals 2. -3 x equals 2. So again, by talking to you, I realize a lot of you probably have a way of doing this. You feel comfortable with it. I'm not trying to reteach you. Like if you've learned this before and you kind of have like your own way of doing it, and you're comfortable with it and you get the right answer when you do it, stick with that, okay? These steps are just more of like, if you're unsure and you really have never understood it, here's the way we proceed through it, all right? So I'll take a volunteer. Does anybody have a volunteer? You can either follow my steps or you can tell me your own way of doing it, how you would go about this problem. Any volunteers? No? Okay, well, if there's no volunteers, let's go through the steps. First, let's make sure it's a linear equation. Yes, it is, right? Clear the fractions. Do you see a fraction? Okay, denominator is 5. Do you see any other denominators? No, right? There's no other denominators. So that's the only number that you need. So basically, that can be what you multiply both sides by, 5, all right? If you only have one fraction, whatever the denominator is, that's what you're going to multiply both sides by. So let's do that. Let's multiply the left side by 5. And then whatever we do there, we do on the right side. Kylie D, are you here? There you are. I'm saying your name right, yes? Okay. So when you multiply the left side by 5, what do you get here?
The left side by 5, 25?
So
That's
this 5 times the 3/5, you have to remember that 5 is like a 5/1. So
Oh.
you're multiplying across. You can, well, you tell me, what would you get?
Negative 15 over 5.
You get -15 over 5, which is what?
Negative 3.
-3. Okay, so Kylie, the way I look at it when I multiply by 5, the way that I look at this is this. 5s cancel. Like one 5 is on top and the other one's on the bottom and they just cancel. But you do it however you want. I just want to make sure you get it right. So this will be -3x. And then Kylie, the other side of the equation is what?
10.
10. Okay, now let's keep going. We've cleared the fractions. Jose, are you there? I don't think Jose is ever going to be here. Okay, Garrett, you there? Garrett, you're Brandon, right?
Yes.
Okay, so Garrett, go through the steps here. Do you see any parentheses?
No.
Okay, done. Do you like terms? On the left side, is there anything you can combine or right side?
No.
No, done. Okay, isolate the variable. Is the variable by itself and then numbers on the other side?
Yes.
Yes, okay. So really all you have to do now is scale. So how would you make that a 1 in front of that x?
Divide by -3.
5 by -3, perfect. There we go. So this will cancel out. You'll get x. Over here, you get 10 over -3. Okay. Good. 10 over -3. Now I have a question / comment to make here. When you write the fraction 10 over -3, is that a positive or a negative number?
Positive.
Positive is on top, right? You have 10 on top, and on the bottom, you're dividing by a
3.
-3, right?
Yeah.
So positive divided by negative, this should be a negative number, right? Positive divided by negative is negative. The reason I'm asking you that is this the same as, I'm asking as a question, is this the same as -10 over +3? Are those the same numbers? So if I take 10 and divide by -3, do I get the same thing that I would get if I took -10 and divided by +3? Anyone know?
Yes.
It is the same answer. It's also a negative number, but they are in fact equal to one another. And not only that, if I put a negative in front of the fraction 10/3, so notice I don't have a negative on the 10 or the 3, but I put a negative in front, this would also be a negative number. And these are equal. What I'm saying to you is this. If you have a negative on a fraction, you can put the negative on the bottom, you can put it on the top, or you can put it out front, and it will still be the same number. Doesn't matter where you place the negative. The only time it becomes an issue is if you have negatives on both top and bottom. If I had a negative on the top and a negative on the bottom, then this just becomes 10/3 because a negative divided by negative is positive. All right. So 2 negatives, you guaranteed it has to be a positive answer. But if the negative is only on one of the numbers, you are free to slide that negative, up, down, or out front. So when you write this answer here, if somebody else wrote -10/3, that would also be correct. All right. Okay. Here's what I'd like for you to do. It's 11:40. I'd like for you to do these problems. Let's see. Trying to decide which ones I want you to do. How about this? Why don't you work on doing those 3? Okay. And what I want you to do is when you are, I'm going to put you, do y'all want to try groups? We've never done groups. Do y'all want to try groups? Keegan, did you say no? No groups. Okay, I won't do it. It's only 3 quick problems. Why don't you work these out yourself? Okay. And then when you're done with all 3, send me a chat with your 3 answers. Okay, so like if you're, I don't know what the answers are for these yet, okay, because I haven't worked them myself. But if, let's just say your answers are -2, and then your next one is, let's say it's a fraction, 3/2, and then let's say the last one is 7/5. Let's just say those are the answers. Just in the chat, type -2, comma, 3 with the little division bar 2, and then the 7 with the division bar 5, with the little slash. Let's just see how this goes. I want to see how fast y'all can get these. Okay, those are them. What I'll do is I'll copy them down and I'll put them on the other page. Let me do it. Hold on. Okay, copy these. There we go. And I'll copy these notes and put those here. Okay, that good? I think we'll go maybe, let's just see how far you get as a class. 10 minutes. See how far you can get in 10 minutes. I'll be here if you need me. You can send me a chat or you can just turn on your mic and ask a question. And this is, the goal of this is not for you to like go type this into some computer program that's going to solve it, or there's programs where you can take a picture of a problem, it'll solve it. So I want to see you do this by hand. If you want, you can send me a chat as soon as you finish the first one and then send me another chat for the second one. Totally up to you. So the second one is probably causing you to scratch your head a little bit. That's okay, just work it through. Give me what you think it is, and then just we'll move on. Go on to the next one. I'm trying to reply to you in the chat if one of them looks off to kind of go back and look at it. We'll just go for a few more minutes here. Okay, I think that's good. Y'all did pretty good. Let's go through these. The correct answer for the first one. The answer for the first one is 4/3, 4/3. Okay. So let's go through it and because some people did not get it. Let's just go through it and see. Maybe you can find where you made your mistake. I'm going to do it down here. So for this one, it's a linear equation, right? It's a linear equation. Clear fractions or decimals don't have any. Clear parentheses. So I'm going to distribute the 3 through. So I should get 2x minus 5x equals 6x minus 12. So I clear parentheses, combine like terms. On the left side, I can put these two together, give me negative 3x. And then this is 6x minus 12. Nothing I can do on the right. So I've done step 4. Step 5, isolate the x. So I'm going to decide, you have different choices here. I'm going to subtract 6x from both sides to get it off the right-hand side. And when I do negative 3x and I take away 6x, that leaves me with negative 9x equals the right side, which is now negative 12. So I've isolated the variable. Now I need to scale it to get a 1. So I divide both sides by negative 9. And that gives me x equals, and here is what I was talking about earlier, negative divided by negative is positive. So this is 12 over 9. But 3 goes into both of these. 3 goes into this 4 times, 3 goes into the 3 times, and you get 4/3. Are there any questions on that one? Let's do the third one next, and then we'll go back to the second one, because the second one is weird. The correct answer for this third one is x equals 1. All right, so let's see why. First thing I do, make sure it's a linear equation. It is. Clear fractions or decimals. I have fractions and I have 7 in the denominator on both. So that will be the number I multiply both sides by, 7. So I multiply the left hand by 7, left hand side by 7. Sorry, 6 over 7. Hold on. Plus x. Yeah, equals 7 times 13 over 7. I distribute through. That gives me 7 times 6 over 7 plus 7x equals, these 7's cancel and I get 13. The thing I think some people forget to do is this step right here, here to here, to get your 7x. Don't forget that part. And then when you do the 7 times 6 over 7, these 7's will cancel and you just get 6. So you have 6 plus 7x equal 13. I've cleared fractions. I collect like, or I'm sorry, I've cleared the, I cleared the fractions. There's no parentheses. There's no combining of like terms. So I need to isolate the 7x. So I subtract 6 on both sides. Cancel. Over here we get 7x equals, and then 13 take away 6 is 7. And then we will scale it to get just x, so we divide both sides by 7. And you get 1. A lot of you got that one, which is good. Any questions on that one? No? All right. The second one is the one that nobody got the correct answer. All right, which I wouldn't expect you to, because we haven't talked about this problem yet. I think a lot of you did it right, but didn't know what to do with the answer. Okay, so let's go through this. It's a linear equation. It is, there are no fractions, no decimals. So I'm going to clear the parentheses. So I've got to take this and look at it as -1, distribute it through. This is a -1, distribute it through. So I'm going to have here on the left, let's see, let's call on someone. How about Garrett? I don't think we've talked to Garrett today. Is Garrett here? Oh no, Garrett, I'm sorry, I forgot to mark you down. How about Alexis G? No, I don't see Alexis G. Raymond, we haven't talked with you. I know you've talked, you've responded, but would you like to go after this?
Yes.
Okay, so when you distribute this negative through, what should this new left side be?
It should be 3 minus 2 plus 7x.
Good. And then on the right-hand side, what would you have?
It'll be 2x plus 5x plus 1.
Good, okay. So we have gotten rid of the parentheses. Let's combine like terms. So you want to keep going, Raymond?
Sure.
What can we do on the left?
You can do the 3 minus 2.
Okay. So I'll give you
and
1.
Make it 1 plus 7x.
Okay, and on the right-hand side, what can you do?
You could add the 2x and the 5x together, making it 7x plus
Mhm.
1.
Plus 1. Okay, good. Corwin. How's it going, Corwin?
Good, and you?
Good, good. We've combined like terms, and now we're supposed to get all the x's on one side and then all the numbers on the other. So how would you go about doing that?
I would minus the 1
On both sides? Okay,
and minus the 7x.
on both sides, right? And something really weird happens, right, Corwin?
Yes,
Like this goes away and that goes away. So what do you have left on the left-hand side?
0.
0, right? Nothing. Everything's gone. So you have 0 here and then equals, and then Corwin, what about the right-hand side?
0.
0, okay. What? X is gone, right? There's no X here anymore. But let me ask you, Corwin, is 0 equal to 0?
Yes.
Yes, right? 0 is equal to 0. That's true. What does that mean? What is this telling us, right? What is this telling us? Here's what it's telling us. It's telling us that if you go back to the original equation and you replace X with any number you want, any number, you can pick a number. I don't care what it is, 5, -2, 1/5. You pick any number you want and this equation will be true, no matter what. Which means that it has an infinite number of solutions. Every number is a solution, which is weird because you would think that all the equations just have one answer. Well, no, it is possible to have an equation where you have an infinite number of answers, where every number is an answer. And this is what tells us right here. This is what tells us that we have an infinite number of solutions, is the fact at the very end, we got 0 equals 0, which is a true statement. So we would say here, infinite number of answers. X can be any number. Does that make sense? Do you believe it's true? Do you believe it's true? You want to check? Let's check it. Somebody give me a number. How about Cambry? Give me a number. Make it a nice number. Don't give me some crazy like, 2,760,000. Give me some number.
5.
5. Okay, so let's just see if 5 works. If I go back up here and I write 3 minus 2 in parentheses 2, 2 minus 7 times 5, does that equal to 2 times 5 minus -5 times 5 minus 1? Okay, so is this true? That's the question. We're saying, yes, it should be true. So I'm going to do this quickly because I don't have a whole lot of time. I'm going to just do this real fast up here. So when I do this, this becomes 3 minus, let's see, I'm going to do 7 times 5, that's 35. 2 take away 35 is -33. So I get 3 take away -33. Is that equal to, and this is a question, is it equal to 2 times 5, which is 10, and then take away, let's see, in this parentheses, this is -25, and take away 1, right? Negative 25, take away 1, that's negative 26. This doesn't, yeah, this is right. Okay, I was like, oh crap, this ain't gonna work. Okay, so on the right, let's do left-hand side. When you do 3 and you take away a negative, it's the same as doing 3 plus the number. And on the right, you're taking away a negative, so it's the same as doing plus the number. And so on the left-hand side, you get 36, and on the right-hand side, you get 36. And that in fact is true, right? So it worked. Cambry picked 5, it worked. What I'm telling you is that if Cambry now gives me another number like negative 10, it's gonna work, all right? So there's an infinite number of answers. It's weird, right? It's a weird problem. So just be on the lookout for something like that, because you need to give, you have to be able to give the correct answer, which is that there are an infinite number of answers. Again, the thing that keys you to it is the fact at the end we got a true statement, 0 is equal to 0. Do you think it's
How would
possible
you
to have
write out
no
that
answers?
answer?
Yeah, go ahead. What?
How would you write out that answer? Like if it was on the test, like how would
Write
you
it in
write
words.
the answer?
There's an infinite number of
Okay.
answers. Or you could just say X can be any real number or any number. You can write either one of these, or you can write them both, as long as you somehow indicate to me that you understand that there's an infinite number of answers, that any number works. Okay. So let me give you a different example where we get something strange. So let's do this. 2x minus 4 times x plus 1 equals 5x minus 2 times 1. Well, I got to make sure this works. Hold on. Minus x, do that. Well, I'm not done yet. There we go. Let's do that one. All right. It's a linear equation, right? Linear equation has no fractions or decimals, but it has parentheses. So I'm going to go ahead and take care of the parentheses now by distributing here, 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 here. And let's see, we still have Keegan. Keegan, we still haven't talked with Keegan today. So Keegan, how do you feel about giving me the next line, the distribution of this -4 through?
I think I can do that.
Okay, what would you get?
Negative 4x.
Okay, so I'm gonna put 2x first, right? This right here.
Right, sorry.
Minus 4x.
Minus 4x. Minus 4.
Okay, good. Equals, now the other side, 5x. Now distribute the -2 through.
Minus 2
Minus 2
plus 2x.
plus 2x. And then you still have over here.
Minus 9x.
Okay, good. Everyone good? Ashley, I think Ashley's the last person I haven't talked to today. Ashley, you doing all right, Ashley?
Yes.
Okay, can you help me combine like terms? On the left-hand side, what can we put together?
Would be the 2 and the -4, so that would be -2x.
-2x, we still have -4, right?
Mhm.
Equals, now on the right-hand side, what can you put together?
So I would combine the 5x and the 2x, and then the -9x.
Yes. So you can do these like together. You can go 5x, add 2x, that's 7x, right?
Mhm.
And then take away 9x, how many x's would you have?
-2.
Yep, -2x. Good. And then you still have what over here?
And then the -2.
Very good. Is that clear, everyone? All right, now I'm gonna get the x's by themselves on one side. So here's what I'm gonna do to do that. I'm gonna add 2x to both sides. That will get rid of it over here. Uh-oh. Is it gonna get rid of it on both sides? Or no? I forgot to add, what did I do? Hold on, I forgot to put the plus sign here, sorry. Do y'all see that? I added it here and I add here, I forgot to put the plus. What's gonna happen on the left side? They also go away, don't they? Which means we have what now? If I try and add 4 to both sides, let's say I add 4 to try and get the 4 off the left side, it'll go away here. And on this side, what will it become?
2.
2, right? So the right-hand side is 2. What's the left-hand side? Everything's gone away. What's the left-hand side? If everything's gone. 0, right? Nothing. So a minute ago, when we were doing this problem and Corwin did it, we got 0 equals 0, right? And I asked Corwin, is that true? Is 0 equal to 0? Corwin said, yeah, it's true. And I said, okay, this is a very unique situation where we have an infinite number of answers and any x we ever plug in is going to work. What happens when you get something like this at the end where it doesn't make sense, right? 0 is not 2, right? 0 is not 2. That is another special situation. And it tells you something about the answers to this equation. It tells you that there is no solution. All right. So when you solve a linear equation, there are 3 possible outcomes. The first outcome is what's been happening on all the problems we did earlier, right? We get answers 11, right? 18/7. So we can get one answer. Right, that's one possibility for a linear equation. We get one answer. The other thing is we can get an infinite number of answers, and that happens when at the very end we get something like 0 equals 0, a true statement. Or we can have no answers, and that happens when we work through the steps and we get some statement at the end that doesn't make any sense. All right. Questions? We have 4 minutes. So what I would do for homework, okay, what I would do for homework just to prepare you for this, I have to be kind of particular. There's certain ones I didn't talk about. So on the homework, which is on page, it starts on page 224. I would do, I would look at probably 28, 29, 30, 31, 32. Let's skip through. So let's say 29, 28, 28 through 31. And then continuing. Oh, wait, I'm sorry. That's not the homework set. I apologize. Here's the homework set. Scratch that. Page 226. So let's see here. Let's say 16 through 29. Okay, but omit, don't do number 20. Only because we have not talked about how to deal with the decimals yet. We haven't done one of those. So try that, all right? 16 through 29 for homework. What I'm telling you is that the test that you're going to take on Tuesday will have problems that are similar to these. I won't go outside of those because as you move on through this, you get some more complicated stuff that we really haven't talked about yet. Okay. All right, so expect again the review to be sent out probably later today. The review will kind of help you see what type of questions I'll be asking on the test. And then when we come in here on Tuesday, there's going to be a certain expectation in terms of you're going to have to handwrite all your work and you're going to have to submit that to me. All right. So I thought we would be back on campus by now to be able to take the test in person, just paper and pencil. So let me bring up I want to bring up our syllabus. I can't recall what I said in the syllabus. So I don't want to say something here. Everyone got the homework 16 through 29, page 226. So let me see what I say about the exams. Yeah, so in the syllabus, this is what I have officially here, okay? Exams will be given in class using paper and pencil, right? In the event we are forced to do remote exams, here's how they'll be done. All right, so there is a very, very like strict procedure for the exams. You're going to be online during, our normal class meeting. It's going to be Zoom. When class starts, I'm going to email everybody the exam. All right. So when the class starts on Tuesday, everyone gets in here. I'm going to email everybody the exam. So you're going to open up the exam. Bless you, Kylie. You're muted. Don't worry. We're going to open up the exam. Okay. And what you're going to do is after you open it, you're going to take a paper and pencil out and you're going to handwrite. You're going to copy all the problems down. Everyone's going to do that. Okay. Copy all the problems down. Once everybody's copied the problems down, then you are no longer you're no longer allowed to be using your computer. You've got to have your hands away from your computer. Everything's, so that you are just doing like a paper and pencil test. Okay. And then when you're done with that, you're going to, so let me keep going. After you copied, you start writing you start doing your work. Okay. During the exam, you may not have your computer on. So this is, I was really hoping we wouldn't get to this, but we're actually having to do this. Here's what I would do. Okay. For Tuesday, I would download Zoom on your phone. Okay. Download the Zoom app on your phone and join our meeting from your phone instead of your computer camera. And the reason for that is that I'm going to want you to be able to move your camera in a way that I can kind of see what's around you. Because it's very easy on a test like this for you to be sitting there, all I see is your face, and little do I know you have all this other stuff out. You're on the web looking up answers. Okay, I need to see more than just your face. So the best way to do that is to use your phone camera and set your camera up on the side. And what this right here is a picture of me. That picture of me is kind of gives you an idea of how I expect your camera to be set up. Okay. Notice it's off to the side and you can see everything around me. So I'm sorry to put this on all of you, but I just found out yesterday, right, that we're going to be doing this. So please, between now and Tuesday, figure out how you can get your phone to be able to show that to me when you're taking your test. All right. Questions? I still have a little bit more to say, but are there questions about that? Make sure you have your charger for your phone so it doesn't die in the middle of the test. Okay, and then the video, I'm sorry I'm going over here. If you have to go, but you need to come back and watch the rest of this video, okay? So that you know what to expect. During the exam, I will be recording all of the video streams that you have coming to me, right? So I'm gonna have a recording of you taking the test. And then once you finish the test, you're gonna send me a chat in the Zoom saying I'm done. And then at that point, what I'm gonna expect that you do is you're gonna take pictures of all of your work. And then you're gonna have to, for this class, because I'm hoping this is the only time we're gonna have to do this, all I want is for you to take pictures of all your work and then try and email those to me. All right, and then I will open them up and I'm gonna actually hand grade your tests, but I have to have pictures of your work. Does that seem like you're gonna be able to pull that off? You see some looks on your faces like, oh shit, The most important thing that you can do is take pictures of your work, because you have to have, I'm only gonna give you 15 minutes from when you finish the test. I'm only gonna give you 15 minutes to email me your pictures. If I don't have your pictures in 15 minutes, I'm not gonna accept it. So the best thing you can do is take the pictures, because when you take the pictures, then we have an electronic document that says what time it was taken and everything else. That is the bare minimum of what you need to do. And then emailing it to me, if you have problems with that, let me know. You know, we can work that out, but. All right. We'll
I have
see
a
how it goes.
question.
Go ahead. What?
Sorry. So I'm not really familiar with Zoom on the phone. So you're saying that when obviously we finish the exam, we take the photos. Do you have to leave the Zoom class to take the photo, or are you able to be on Zoom and take the photo at the same time?
When you're done with the test, you're going to send me a chat saying I'm done with the test, and
Right.
you can leave the Zoom session. You can leave.
Okay.
But then the clock starts and you got 15 minutes to get me the test.
Awesome. Okay, cool.
Yeah, so you don't have to worry about being on Zoom while you're taking pictures and all that. Just, you know, just leave and get your pictures, send them, and be done. I imagine there's going to be some speed bumps here, all right? Really the big thing for me is that I want to be fair to the class, all right? And fair means I want to hold everyone to the same standard in terms of, you know, if Raymond's got his camera and I can see everything around Raymond and I can tell that he's doing the work, I need everyone to have that same level of I'm looking for, what's the word I'm looking for? Integrity, okay, in terms of what you're doing. I know it gets very, very tempting as a student at home. You come to a test, you get nervous, you start panicking. And because you're at home, you feel like you can go find the answer somewhere. You just want to get it right. And I don't want any of that to happen here in terms of finding out that somebody's cheating. All right. I have zero tolerance for cheating. All right. None at all. So if you cheat, if I find out you're cheating, and this is, I'm not trying to be threatening to you. Okay. I'm just trying to get you to understand, like a lot of times in a class like this, you're coming out of high school and they treat it a little different than in college. In college, you know, if there's an opportunity for you to learn a lesson, we'll learn the lesson. But for the most part, if you're cheating, I drop you from the class. That's it. It's over. All right. And I report it to the college and they have it on your record that you were cheating. All right. And then if that happens a few times, then they can actually drop you from the college and it stays on your record. And I'm not trying to, again, I'm not trying to threaten you. I'm trying to get you to show me what you know, right? Show me what you know. And if you panic and you freak out, then you panic and you freak out. And that's what happens. And then we have to work on that. All right. But cheating should never be the path you take. All right. Let's see how it goes. All right. Let's see how it goes. It's, like I said, it's not a ton of material. And from the responses that I got just now on that, when I asked you to do those problems, I think a lot of you did well. But with the linear equations and even with the adding and subtracting of fractions, we all know as math students that there's just so much room for error, right? Little mistake, and then everything's off, right? So you want to be meticulous. And that's why I want to see your work. Okay, that's why it's so important for me to see your work. If you get the correct answer and you have no work, that means nothing to me. If you have the wrong answer, but you have all the work and I can see your mistake, then I give you credit for that work, right? So I'm always wanting to give partial credit. So see how it goes, all right? Questions? Sorry to go over here. Any questions?
When's the exam?
Tuesday, when we come to class, all right? So you'll just log in and, you know, the only things I guess you'll need for the test is you'll need some blank paper, all right? And let's do this. I forgot. I'm gonna do this for every test for you, all right? I'm gonna allow you to have one page, front and back, and you can put any formulas or steps or procedures on that page. So you can, like, you know how the steps I just gave you? If that was helpful to you, where are they? If this was helpful to you, you can put that here. If you want to have the formulas for like how to add and subtract fractions, go ahead and put those here, all right? What you cannot have on this sheet is just worked out problems. Okay, you can't just like take a bunch of problems and work them out and say, oh, that's my reference sheet. No, And so what you'll do is at the beginning of the test, when the test starts, I'm gonna have you hold the reference sheet up to the camera and show me once it zooms. Oh, I think I'm out of zoom now. So you'll have to show the camera just front and back your reference sheet, and then you'll submit it. Whenever you take pictures, you'll submit it also. So, yeah, all right. Anything else? So sorry, I lost track of time.
I
My
have
other classes
another
end at
question.
12:40, so it's like, I always think I've got more time. Say again?
Sorry, I have another question. So I know that during the classwork, you allow us to use our calculators. Obviously, for the exam, we won't be allowed to, right?
No, you can.
We
You
can?
can
Okay.
use your calculator, but you can't use it, like if I ask you to add two fractions,
Right.
I want you to like show me that you're getting the common denominator, or you're doing that little cross method that we talked about. Now, you can use your calculator to check your answer. That's fine, okay? But I do not want to just see answer with no work, okay? I want to see that you understand the processes here. Any other questions? All right, make sure you're ready to set that camera up. Okay, on Tuesday, practice it if you need to, practice it, just set it up. And I've had students show up to the exam, they're like, I can't get it set up. I'm like, okay, you've had time. You could have like went and got a chair or something, you could have like thought this out a little bit before you got here, So I'm going to be a little lenient with you because we're not even supposed to be doing this, but let's just try and do the best we can. All right. All right. You're free to go.
Thank you.
Have a good weekend.
Thank you.
You too.
Allison, you still there? No.
Have a good weekend, sir.
You as well. Thank you.